would like to present a small talk on the product design aspects of engineering. When we select a problem, first we have to define a problem and then select the problem. So when we select a problem, we have to understand how important it is. And after selection, we have to arrive at a control solution, that is control convergence. We have to have ideation and then brainstorming and control convergence using the Pierce method. After arriving at a single solution, we have to go for product design specification and detailed product design specification. One is called PDS and the next one is called TDS. Then we have building of prototypes. I shall just try to explain this with a simple example of defining a problem and other aspects. When we define a problem, we have to take from the reality. So real problem is very essential for us. As a country, we are a member of Mission Innovation countries, and our agenda is to develop green energy generation and distribution, 100% green energy generation and distribution over a period of time, that is up to 2050, we will be able to get pollution-free energy. So in the process, we have to go for green energy areas. Solar power is one which is a beaten area already now, and then wind power, which is still developing and it is site-based, and then the water power, which is still developing. It is not possible to develop so easily because there are so many constraints in that. So when we define a problem, actually, need for a problem is we have to go for a green energy using the water turbine, and that is very essential for the future of the country also. Then based on ideation and brainstorming and control convergence, let us say we have arrived at a simple problem of defining a hydrokinetic drum type of turbine. Here, there are only three principles that are very essential. One is hydrokinetic energy, which is off into rho into A into V cube, where rho is the density of water, A is the bluff area of the turbine, and V is the velocity of flow. Then we have what is called the Fonda effect, which is basically the wall attachment effect. So supposing we have a tap through which the water comes, when we place our hand near that, the water will try to attach to the particular hand. So the water actually takes the path of attachment. So this is very essential for a turbine which is going to work in the hydrokinetic environment. Third, we have what is called the chevron plate, which is just a plate with a profile like this. So these are projections actually. These plates are used for condensing the steam in the steam environment, that is in the boilers. So based on these three principles, I shall just try to explain the prototype model which has been built already with the help of a simple design. So we have the basic drum, which is having a diameter and a length. So over this, we have the profile, and then we have a single shaft. With the hub, we will have a bearing, and then connected to a structure. So when water flows perpendicular to this, actually the water attaches at this point, and then it flows like this. So there is a reaction on the chevron plate design. So it's a plate which is actually rolled into a drum. Now, when we fabricate this, after making a small design, say a 400 millimeters length of turbine and 300 millimeter diameter of the turbine, it is actually a working model with 50 watts capacity. What we do is, we take a FRP sheet and then roll it as a drum, and then use a non-metallic welding and then close it with the end plates, and then have the shaft. And then the chevron profile is separately made, and again using the non-metallic welding, it is welded onto this. At the end of the shaft, we use a very small gearbox to increase the speed, because when we put anything in the water, the speed reduces. So this is a speed up gearbox. And then from this, we take the output. We take a small permanent magnet generator. So it's actually an axial flux permanent magnet generator. From here, we take the power output, connect it to a grid using a grid type inverter. So three things we have understood now. One is the hydrokinetic energy, how this can be transferred as a usable electrical power using the Fonda effect, which is basically a wall attachment effect. And then we have the chevron plate, which is used in the boilers for condensing the steam to get the pure water. So we have adapted three different areas, basically the hydrokinetic energy, Fonda effect, and chevron plate. So a design basically can be adapted. A design can be adapted from various aspects of engineering and technology. To summarize, what we do is we have to develop the prototype after that. So a product design specification is very essential. So we have to define what is the diameter of this turbine, what is the length of the turbine, and all. So here we have developed a 400 millimeters length and a 300 millimeters diameter turbine. So at the end, we have placed a gear. There we'll have to place a permanent magnet generator, which will work at a very low speed. We need to have a speed up gearbox, because when we put it in water, it is going to reduce the speed. Now, after making the product design specification, which is very essential, we have to make all the details of this, and then we have to make a total design specification. And this model can be scaled up. That is the advantage of this. Scaling up means, see, here is a density, water we cannot change, area we can change, because it is a product of length and diameter. So this can be changed to some extent, because we are going to use it in very big channels. And then velocity is very essential. We can increase the velocity by using the ducts. When we use the ducts, the velocity can be increased to 4 times. For example, if a turbine can develop 1 kilowatt at 1 meter per second velocity, if the velocity is increased to 2 meters per second, then it will become 8 kilowatt. If it is 3 meters per second, then it will become 27 kilowatts. So the velocity can be increased by increasing the size of the duct. And if it is an open channel flow, then we can have the taper channel for increasing the flow. The analysis can be done using the computational fluid dynamics softwares, which is basically developed based on the equations, Manning's equation basically, and that is used for finding out the flow that is taking place in this, because it is a new design where we are using the chevron profiles. So we have to go for an analysis which will give the actual force that is coming on the system or the turbine. Now, these types of prototypes, this is actually a lab model. So this can be used for demonstrating the basic principle to the funding agencies, which are basically Department of Science and Technology and Ministry of New and Renewable Energy. So I shall just show the working of this. Just if I touch this, it will start working. You can just see the rotation comes. So we have 2 bearings at the end, which are basically roller bearings, and a simple structure. This is actually a lab model. A video of testing of this is also available. Thank you very much.